Hello, I am Shigeru Inagaki.
I am Kazunobu Nagasaki. We are professors of Institute of Advanced Energy, Kyoto University. Today, I'd like to briefly introduce to you the fusion plasma research being conducted in our laboratory.
Energy security and environmental protections are perhaps the most important issue for the sustainable development of our modern society. At the Graduate School of Energy Science, Kyoto University, we are researching the solution of energy problems. Our laboratory is a course in collaboration with the Institute of Advanced Energy. In our laboratory, we are performing plasma confinement experiments to realize fusion energy together with our master and doctoral students.
This is a building where our laboratory is located. I will now introduce what kind of research our students are doing in our laboratory.
Fusion is the nuclear reaction in which two light atoms, such as hydrogen, combine together or fuse to form one heavier atom, such as helium. In the process, some of the mass of the light atom is converted into energy. To make fusion happen, the hydrogen atoms must be heated to very high temperature so they become a plasma. Plasma is one of the four fundamental states of matter. A significant portion of it contains charged particles, that is, electrons and ions. The stars across the universe, like our Sun, are boson plasma and natural fusion reactors. Today, we are studying that the very same phenomena so that we can create the Sun here on the Earth for the realization of controlled fusion reactor. In order to realize fusion reactor, high-temperature plasma should be confined long enough for fusion to occur. Sun confines the plasma by gravity, while we confine the plasma with a twisted magnetic field line structure so-called a Heliotron field. The Heliotron field was devised at Kyoto University. The Heliotron J is a plasma confinement device with the latest Heliotron field at Kyoto University in Japan. The flexibility of Heliotron J magnetic cores has the capability of controlling confinement properties of Heliotron field. The goal of the Heliotron J experiments are optimization of the Heliotron field, development of equipment and measurement technologies for future reactors, understanding the physics of magnetically confined plasma. We are trying to confine the plasma in a magnetic vessel. It is turbulence that determines the dynamics and loss of plasma. Turbulence forms structures such as flows and convective cells which determine plasma losses. Our purpose is to clarify the structural formation of plasma turbulence to realize magnetic fusion. Experimental research requires diagnostic device. Lights and microwaves are used to observe plasma at 10 million degrees Celsius. We develop new devices that have never been used before. Preparing the instruments is very important in experimental research. Plasma experiments are performed remotely from the control room. During the experiment, huge data are analyzed in the control room. I am most excited when I see plasma signals. The student in charge, called the week shift, will summarize what kind of experiment were performed and what kind of plasma was produced. Students and staffs discuss the result of our research together on a weekly basis. The result of data analysis and sometimes simulation results are integrated to clarify the nature of the plasma. Here, new plasma phenomena are discovered.
You can study in our Heliotron J group as a graduate student in Graduate School of Energy Science, Kyoto University. Why don't you join us in our research for nuclear fusion? Please do not hesitate to contact us if you have a question.